When you are working with algebra, specifically multiplication and division of algebraic terms, there is a nice technique that you can remember, and I just call it SNV. It stands for signs, numbers, and variables, in that order, or a different order if you like, but you do them separately. Every time you multiply or divide, do it separately. So you do the signs first, for argument's sake, which is a plus times a plus is a plus, or a minus divided by a minus is a plus, or whatever those rules are applicable to the specific question that you are working with. Then the numbers are just simply your times tables, or your numbers. It's a number divided by a number, or a number multiplied by a number. And then your variables, you use your exponential laws, where you've got your first exponential law. Let's say it's x to the power of 2 times by x to the power of 3 will give you x to the power of 2 plus 3, or then x to the power of 5. That's the first exponential law. The second exponential law is if you have something like this, where your base numbers are divided, then you will subtract. So that will give you x to the power of 4 minus 4, which is equal to x to the power of 0, and that is equal to 1 anyway. Anything to the power of 0 is always equal to 1. So that's the second exponential law. And then your third exponential law will be something like that, inside a set of brackets, to another power. So let's say to that, and that will then give you x to the power of 4 times by 2, which is equal to x to the power of 8. Now, some textbooks take that third law, and they say, but what if I have, for instance, 2a to the power of 2, x to the power of 4, in brackets to the power of 2, something like that. So now I've added another couple of terms inside the bracket. But the same technique applies. So this doesn't suddenly become the fourth or the fifth exponential law, although some textbooks do refer to that as the fourth and the fifth exponential law. It still remains the second or the third exponential law, because the 2 has an exponent of 1, so you multiply that with the exponent of the bracket, exactly like we multiplied there, the exponent with the bracket. So that will give you 2 to the power of 1 times 2 is 2 to the power of 2. A to the power of 2 times by 2 is a to the power of 4, and x to the power of 4 times 2 is x to the power of 8. And there you have the final answer. So in my opinion, all of this is still just one law. It just happens to have more terms inside of them, but it's still the third exponential law. So the same will apply with the first law. For instance, if you have 2, let's say 2 times by x to the power of 2 multiplied with 4x to the power of 3, then you can write that 4 as 2 to the power of 2 times by x to the power of 3. And what you'll do in this case is you'll take the 2's and handle them separately. So that will give you 2 to the power of 3 and then x to the power of 5. Because with the first exponential law, you add the exponents. That is basically what the first exponential law says. You can add the exponents if you multiply the same base numbers. That's the distinction. So we handle the 2 separately from the x's because it's different bases, but then you just add the exponents. So we don't suddenly change that into a 6th or a 7th or an 8th exponential law. It still remains the first exponential law. And for the same reasoning, I'm saying no matter what is inside the bracket, that is still the third exponential law. But you use those laws of exponents with that last step, the variables. So whenever you multiply algebraic terms or divide them, like in algebraic fractions, just remember this: signs, numbers, variables.